Hey folks, welcome to another episode of ASP.NET Core from Zero to Overkill. In this episode, we'll continue the integration with Identity Server, part 4 of 5, I think. And today we're going to talk about the backend for frontend, the integration that it requires with the REST. So, in the previous episode, we configured the API to require authenticated users, so using an access token as the user's identification, JWT. So in this episode, we'll configure the backend for frontend to authorize the user as we require it, and then after getting the required information, provide the access token when making API calls to the group management service. We refresh the access token when it's about to expire, and also add support for Crosssite requests forgery token, as we saw in previous episodes related to MVC and Razor pages. In this case will be a little different, but it's important nonetheless to protect the users from these kinds of attacks. So, the usual plugs. If the videos are being useful, please consider liking the videos, sharing, so we get more people over here, and provide feedback so we can improve the future videos. And with this, let's go. So let's start by looking at the code, or better yet, let's start by looking at the commits that I made. So these ones over here are front-end stuff, view, so this is for the next episode. In this case, today we're only focusing on this part, so the C# part. So what did I say we were going to start with? Configure the authentication. So to authenticate the user, I created over here an auth, so a controller for authentication. With a couple of things. For starters, created an info endpoint, so when the front end starts, the single page application starts, it makes a request to get information about the user that is authenticated, if he's authenticated. If not, it's not. Let me go over here to the browser. So delete the cookies. Let me open this over here, and if we refresh, you'll see info for one unauthorized, so it can't get information about the user because there is no cookie, it's not authorized. So back to the code, and over here it gets information about the user, just to know that it's logged in. Because the cookies, the authentication cookie is HTTP only to be more secure. So on the single page application side, know if the user is logged in, it's a way we make a request, and only if the user is logged in, then the information is provided. So, but we'll see this working in conjunction with the front end in the next episode. And over here we have a login, which basically requires, I think this is configured somewhere. Let's go to startup. Yes. So I configured somewhere. Which wasn't here, was somewhere. Let me check. We'll take a look at this in a moment. Oh yes, so we have here. Yeah, let's start with this. So we are configuring authentication for the front end, which there wasn't. It uses cookies, and the default challenge scheme is OpenID Connect, which is configured down here. So the cookie part we are using these custom cookie authentication events. We'll see in a moment what does this do. And then we configure OpenID Connect. So sign-in scheme, it's cookies. The authority, like we saw previously, is the identity provider, so the authentication service. The usual disable metadata requiring HTTPS because we're in development. Client ID is web frontend, like we saw when we configured. Let me see if we have this here. Over here, identity. So client ID web frontend, secret was secret. So getting back to the back for front, the secret, we want response type code, save tokens. These saves is stored in the application, so there can be used. They are stored in the cookie, yeah. By default it's stored in the cookie, but we can override this right now. It works. So get claims from user info. So the ID token, it like we talked about, it makes a request when it gets the access token, then makes a request to get information from the user. So right here, and then scopes that it needs, group management and offline access. And then I'm making here a trick that is after authentication, or better yet, if there is authentication, the user is not authenticated, it only redirects to the identity provider if the request is to the login path. If the request is not to the login path, it means we are assuming that it's an API request, so it's made by the single page application, and we don't want the AJAX requests to be redirected to the identity provider. We want the AJAX requests to get a 401 because the user is not authenticated. So only when the path starts with auth login. So if we go over here, only when the path, like you can see down there, starts with auth login, it redirects to the authentication service. If not, 401 unauthorized. Don't know if there is a better way, but this works well enough. So getting back to the auth controller, this endpoint only serves two purposes. When we send the user down here, it gets over here. So if the user is not authenticated, it will redirect to the authentication service. And when it gets back, it just redirects to the return URL of the single page application. So to get back where the application was, for instance, imagine we want to go to groups, and it redirects over here because, okay, that was a bad example because that involves front-end code. But basically, because that requires authentication, in the front end we're redirecting to the API login page, and the API login page then redirects to the identity provider. So when after the flow, the authentication flow is done, the authentication service redirects back to login, and because the user is login, we can redirect to the single page application wherever it was. So this is like some kind of tricks to make the authentication go. So offline access, yes, allow, go. And now we go back to the groups because that was part of the redirect URL. Okay, so this is the login part over here. This is configuration, and like I mentioned in the previous episode, nothing from here is specific to identity server. I'm using these constants which come from identity model library. Let me check the CS project. So I added a reference to identity model, which is a library by the guys from identity server, but it's generic. These are just constants useful in this case for OpenID Connect stuff. But nothing from here is identity server specific. We could use any other provider that implements the same functionality. In this case, because we are in this using .NET for everything, we are using identity server. Okay, so these were the part of the authentication, most of it. Okay, so let me check the notes. Provide access token on API calls. Okay, so we saw this part. Now let's take a look at this. So we are using, let me close everything, we'll get back to there. In the groups controller, so we are making all those requests, HTTP client. And somewhere, which is not here, we could, when making the requests, pass the headers. But because we are doing this everywhere, we can put it in a place that's reused. Where did I put it? Probably here. HTTP client. Yes. We can add, this is more specific to HTTP client. This isn't really identity server integration, but this is what we need to do. So we can create an HTTP message handler that takes care of getting the required token. So after we are authenticated, the token is on the HTTP context, so we can use it. So I created an HTTP delegating handler that gets, let me make this smaller. Add some entries over here. So this is delegating handler. We can add multiple, which intercepts the requests made by the HTTP client. And we use the HTTP context accessor. And then when a request goes, so sends a sync, in every request, we get the access token from the HTTP context, and we add a bearer token authorization header. So header's authorization, and we add a bearer token with the access token. And then we let the request flow through the HTTP client. Like I mentioned, we could do this on the controller. We could just go to HTTP context, get tokens, get the token, and then in the client pass the headers and all of that. But as we are using it everywhere, it's just easier to do it this way. So like we have this, so in a startup we just needed to say we want this message handler. I added it to the service, so over here to as transient, and it is used every time we make a request. It goes through here, and it's one less thing we must do. If not, in all requests we had to do the same thing, and it's annoying and unneeded because we can just do it once. So that's it for this part. So provide the access token. Now in this context of making things really reusable, particularly in this backend for frontend, that all it does, at least so far, is making requests to other APIs, the refresh access token can also be achieved in a similar fashion. Of course, not on the delegating handler of, okay, it could be Initially I was doing it like that, so what I initially done was over here in the message handler, before I checked if the token was valid, and if it wasn't or it was about to expire, refresh over here before sending the request. That's an option. But then I found out there's another strategy which seemed to me even more interesting, at least in this context, this web context. That is, over here on startup, let's check over here, and I'm registering a token refresher and this custom cookie authentication events that you have seen here. So over here, for instance, options.events, we have events for things that happen during sign in, sign out, stuff like that. So, and we can override them. Another option is to pass this events type so we can access dependency injection in our methods. In this case, I want to access a dependency injection because we are going to make a request to refresh the token. So this is an option. So created this custom cookie authentication events, and in this class we override from the default cookie authentication events and can override what we want. In this case, I overridden the validate principle, so it occurs every time. So in every request it goes through these methods to validate that the principle from the cookie is valid. And what I'm doing over here is, in every request I'm checking if the token that's stored in that request it's still valid. So instead of in every request done by, for instance, the controller, imagine right now we only have each operation makes one request, but imagine that we had a composition of requests eventually we'll have. So imagine that get all made like 4 requests. In all requests we would be validating if the token is valid. There's no problem, but using this approach that I found out while doing this, we just do it once for each request. So one can argue that if the request won't make any external request, it's a waste. But in this specific case of the BFF, I think most of the times we will make some request. So it's important to have the token valid so we can do this. And it was a way to experiment with something I did not know about. So on validate principle, we try to validate. I created this helper, token refresher. We'll just take a look in a moment. So we get the token, the refresh token, and we get the expiry date. And if the token should be refreshed, this will do it. And if it fails, we will reject, say that the principle is no longer valid, because if we can't refresh the token, it means there might be a problem, but we won't be able to make requests in the name of the user. So might as well sign out the user, because we need him, her, to re-sign in so we get the access. So if failed, we sign out. If it didn't fail and the tokens are renewed, then we update the tokens. There's also the option that the token doesn't need to be renewed, so we just skip this part. But if the token needs to be renewed, this is the way to do it. So we context properties and update the access token, refresh token, and expires. All of this. Should renew means the cookie should be renewed because we changed things in there. Now, let's just take a look at the part of refreshing. So This is the token refresher. Start by the interface. So it basically just has one method, try refresh token. If required, we pass the refresh token and the expiration. And going back over here, we need an HTTP client to make the refresh request. iDiscovery cache, which is also from Identity Server, or not, from the identity model library. So because there are several ways. One thing I really didn't mention this in the other episode, but we can, the identity providers normally expose an API to a page that tells us what are the endpoints for the various operations. If not, we would have to know every endpoint or be like a convention, which is dangerous, or we should configure everything. Instead, there's an endpoint to do that. Let's take a quick look. So IdentityServer4, well known. I think this is it. Okay, it would be nice to see the JSON of this. So, but if we go localhost 5005, yeah. Pretty print, yes, please. Why don't you help? Click the button. What button? Where is this button? On the bottom status bar. This is printed. Not really. JSON pretty. Okay, so this endpoint is the discovery endpoint. I forgot to mention in previous episodes, which tell us the endpoints for the various operations. User info, token, authorize, logouts and stuff, scope supported, claim supported, a lot of things. So this iDiscovery cache handles requests to that and caches, of course, the information. So now, when we implement the try refresh token, if the refresh token past is empty, failed, if expired is greater than the threshold, which is plus token refresh threshold, which is 30 seconds, and it's hard coded, but okay, so this is for tests. If the token will expire in the next 30 seconds, we will refresh it. If not, no refresh needed. So discovery, and then we use this comes from identity model again. If not, we would just have to create the HTTP requests by hand. But with these helpers, again, identity model is not identity server, is an independent library that happens to be by the same guys. And we make a refresh token request with the discovered token endpoint, which is token endpoint is over here, with the client ID web frontend. Again, shouldn't be here, secret, and the refresh token that we received. Then we get the result. If the result is an error, we say that the refresh failed. If not, we prepare the new access token, the new refresh token, and the new expiration date, and return a success. This is just a token refresh I created, little helper class to handle all of this. Okay, we also calculate the new expiry. And we are back to, I want to get back to the custom cookie. And that's it for the refresh. So we're using this functionality from ASP.NET Core Authentication. So we can use these cookies and unvalidate the principal. We do this instead of in every request. But yeah, as we saw so far, nothing of this is specific to IdentityServer. Even knowing this, because this is part of the spec, any other identity provider implementing the spec will have that well-known endpoint that I closed. This well-known endpoint, and we will be able to use it. Okay, let's get back here. So we check this out, check this out, check this out. So Crosssite request forgery on this backend side, because the frontend side we'll see in the next episode. So we can close all of these. In the startup, I think there's something going on in here regarding that. Yes, we had anti-forgery services. Okay, I think that's all. And by doing this, it's validated, because by default it doesn't validate, and as we don't want to be putting attributes in everywhere, we can do it this way. I don't think, yeah. We need services regarding the anti-forgery. We configure the name of the header. That will be, because we will include the token in a header over here. Or better yet, the front end will put the token in a header, and then it will be validated on the backend in each request. And over here in the MVC configurations, we had the validate anti-forgery token, because if we didn't do this, we would need to go here and on these requests validate anti-forgery token. Instead, as before, we had a filter that does it for us, and we want this everywhere, so we do it. And over here, this is the header that will be validated. Over here in the auth controller, when the single page application does that first request to get information about the user, besides checking that the user is logged in or not, we add a cookie, which is the token. We create the token. It's created and stored in the HTTP context. And we put it in a cookie that is not HTTP only, because we want the JavaScript, so in this case our Vue application, to use this, to read this cookie and put it in the header for the requests. Then we can validate what is in the cookie put by the backend, and the header that the front end sent. So we validate that both match, and it's not an invalid request. So, and after that we just pass the name back to the front-end application. We are not using it yet in there, but we can. And that's mostly it. It seems easy after it's done, but it's a bit of work. So hopefully this rather quick overview is helpful to you when you have to do something like this. Because yeah, I know the video is fast and seems easy, but doing it, unless you do regularly, one forgets about stuff. So yeah, I think that's it regarding this. Done. So in the next episode we'll see the adaptations that were made on the front end for this. So basically for Crosssite request forgery, and to have the login part and securing the application. So that's about it for this one. Hope you enjoyed it. Feel free, as always, to leave some comments and questions and provide feedback as you want, as long as constructive, of course. And hopefully I'll see you in the next one. See yous!